Remember in our example, I1t is 5%. I1t plus 1e is 6%. I1t plus 2e is 7%. I1t plus 3e is 8%. And I1t plus 4e is 9%. Now, what we want to get is INT. I1t, I2t, I3t, I4t, and I5t. The answer according to two theories, expansion theory and liquidity premium theory. You know, I1t is 5%, that is given. So it's 5%, 5%. I2t, expansion theory says I2t should be the average of the next two one-year bond interest rate. Therefore, it is 5% plus 6% divided by 2, which is 5.5%. But the liquidity premium theory says, in addition to this 5.5%, you have to add liquidity premium. And according to our assumption right here, 1-year bond liquidity premium is 0. 2-year bond liquidity premium is 0.25%. 3-year bond liquidity premium is 0.5%. 4-year bond liquidity premium is 0.75%. 5-year bond liquidity premium is 1%. So in addition to this 5.5%, liquidity premium theory says that you have to add a liquidity premium of 2-year bond, which is 0.25%. Therefore, it's 5.75%. I3, the average of 5, 6, 7, which is 6%. But the liquidity premium theory says that in addition to this 6%, you have to add the liquidity premium of a 3-year bond, which is 0.5%. Therefore, it is 6.5%. Doing the same thing, 4-year bond interest rate, average of 5, 6, 7, 8. The average is 6.6%, at 6.5%. And again, liquidity premium theory says, in addition to this 6.5%, you have to add liquidity premium for the 4-year bond, that is 0.75%. So liquidity premium theory says 4-year bond interest rate today should be equal to 7.25%. 5-year bond interest rate, average of these 5, which is 7%. Liquidity premium theory says, in addition to this 7%, you have to add liquidity premium for 5-year bond, which is 8%. That's the summary of these two numerical examples that we went over for expansion theory, which is this one, 5%, 5.5, 6%, 6.5, 7% of the expansion theory, and the numerical example for the liquidity premium theory. Liquidity premium theory, 5%, 5.75, 6.5, 7.25, 8%. Again, which theory is correct? This one is correct. Okay? When you are drawing yield curves implied by these two theories, what do you get? That is, if you want to draw an yield curve of terms 1, 2, 3, 4, 5, according to the numbers we got here, expectation theory says 1-year bond interest rate should be 5%. 2-year bond interest rate 5.5. 3-year bond interest rate 6%. 4-year bond interest rate 6.5%. 5-year bond interest rate 7%. So this is the yield curve implied by expectation theory. Is this the yield curve you're going to observe in the market? The answer is no. Why? Because the expectation theory is wrong. So the yield curve implied by expectation theory is wrong. Therefore, we should draw yield curve implied by the correct theory, which is the liquidity premium theory. So the liquidity premium theory says 1-year bond interest rate is 5%. 2-year bond interest rate is 5.75. 3-year bond interest rate is 6.5. 4-year bond interest rate is 7.25. 5-year bond interest rate is 8%. What's the difference between these two? 1%. What's the difference between these two? 0.75%. What's the difference between these two? 0.5%. That's exactly the liquidity premium, right? Because you add liquidity premium on top of the interest rate implied by the expectation theory. So when you draw that, what do you get? You get the liquidity premium theory implied yield curve. And this is the yield curve that you actually observe on the market. Why? Because liquidity premium theory is the correct theory. And what's the difference between these two? What's the relationship between these two? Can you see that? You pivot up the yield curve implied by the expectation theory to get the liquidity premium theory yield curve. Because 1-year bond interest rate is the same, no liquidity premium. But the liquidity premium is getting bigger and bigger. Therefore, you pivot up the expectation theory yield curve to get the true yield curve, that is, the yield curve implied by the liquidity premium theory. Therefore, comparing the yield curves implied by the expectation theory and liquidity premium theory. Liquidity premium theory yield curve is steeply upward. Steeply upward. More steeply upward. That is, you pivot up. The relationship between these two yield curves, that is, one implied by the liquidity premium theory and the other one implied by expectation theory. The relationship between these two yield curves are very, very important. Why? Because what we are observing on the market, what we see on the market monitor, what we are seeing is this yield curve. This green yield curve implied by liquidity premium theory. It is not this black one, the yield curve implied by the expectation theory, because this theory is wrong. But it is this curve, yield curve, implied by the expectation theory that is very useful. Let me say it again. What is useful is this curve, but we don't observe this curve. What we are observing is this curve. So the relationship between these two is very, very important. Why? Let's go back to the expectation theory. Remember this? When we are talking about expectation theory, we say that when short-term interest rate is expected to rise, then you will see an upward sloping yield curve, according to expectation theory. If people expect short-term interest rate to stay the same, then you will observe a flat yield curve implied by expectation theory. If people expect short-term interest rate to fall in the future, then you will observe a downward sloping yield curve implied by the expectation theory. This is the expectation theory. Can you observe people's expectation? The answer is no. You don't observe people's expectation. But expectation theory tells you that by observing the yield curve, actually you can derive people's expectation. That is, if yield curve is upward sloping, then the market expects short-term interest rate to go up. If yield curve is flat, then the market expects short-term interest rate to stay the same. If yield curve is downward sloping, then the market expects short-term interest rate to go down. So yield curves implied by the expectation theory tells you what the market's expectation of the future is. That is very important. Unfortunately, these yield curves are not observed on the market because expectation theory is wrong. So this is a dashed line. We don't observe the yield curve implied by the expectation theory. But we do observe the yield curve implied by the liquidity premium theory. So how can we derive the useful, unobservable expectation theory yield curve from the observable yield curve implied by liquidity premium theory? The answer is, when you observe this yield curve on the market, you pivot it down to get the expectation theory yield curve. And if the yield curve is upward sloping, then you know the market expects future short-term interest rate to go up. If the resulting yield curve is flat, then you know that the market's expectation about future interest rate, short-term interest rate, is staying the same. Therefore, let's consider these four situations. If you go to the bond market and check a yield curve, and you see that the yield curve is steeply upward sloping, then you pivot it down, it is still upward sloping. So this is liquidity premium theory. This is expectation theory. Then this yield curve tells you that the market expects short-term interest rate to go up. If you observe a mildly upward sloping yield curve, then you pivot it down you will get a relatively flat yield curve implied by the expectation theory. And expectation theory tells you that the market expects the short-term interest rate to stay the same. If you have already observed an yield curve that is flat, and then you pivot it down, you get a downward sloping yield curve implied by the expectation theory. That means people expect short-term interest rate to go down. If you are observing a downward sloping yield curve already, and you pivot it down, that means the market expects the short-term interest rate to drop sharply. That's how you can derive people's expectation from the observation of yield curve. And that is why yield curve is very important in the financial market and in the macro economy. Now, let me go over two more examples to show what I mean here. In this example, the current 1-year bond and 2-year bond interest rates are both 4%. What does that mean? Current 1-year bond interest rate, I1T, is 4%. The current 2-year bond interest rate is also 4%. Current 2-year bond interest rate is also 4%. 1-year term premium, 2-year term premium, that is, 1-year term premium L1T is 0%, of course. 2-year term premium L2T is 1%. Then the liquidity premium theory predicts the expected 1-year bond interest rate next year. So what is it asking for? Expected 1-year bond interest rate next year. So the liquidity premium theory says 2-year bond interest rate should be equal to the average of the next 1-year bond interest rate plus a 2-year bond liquidity premium. Do you have 2-year bond interest rates? The answer is yes. You observe that interest rate, which is 4%. Do you have this interest rate? Yes. You observe that from the market. Now, what the economists do is to estimate the 2-year bond liquidity premium, and the result is 1%. With this information, the market can derive people's expectation about 1-year bond interest rate next period. That is, 4% is equal to 2, the average of 4%, and this plus 1%. So minus 1%, minus 1%, 3% is the average of these two. Multiply by 2 on both sides. 6% is 4% plus answer. So the answer is 2%. What is the current 1-year bond interest rate? 4%. And by estimating this liquidity premium, the economist can show that this 1-year bond interest rate is going to drop 2% to 2% next year. Therefore, market expect the 1-year bond interest rate to drop from 4% to 2%. That is by dropping 2%. So shorter term bond interest rate, 1-year bond interest rate, is expected to go down by 2% to 2%. The next example. The current 1-year bond and 2-year bond interest rates are both 4%. So again, 1-year bond interest rate today is 4%. 2-year bond interest rate today is 4%. And the market expect 1-year bond interest rate to go down by 1%. So market expect 1-year bond interest rate to go down by 1%. What is the 1-year bond interest rate now? The answer is 4%. So market expect this interest rate to go down by 1%. So market expect 1-year bond interest rate next period to be 3%. Go down, 1-year bond interest rate to go down from 4% to 3%. That is, go down by 1%. This implies that 2-year term premium. So the question is asking for 2-year term premium. Does this say any theory? The answer is no. If the question does not say any theory, which theory should you apply? The answer is liquidity premium theory, because it is the correct theory. You don't have to specify this theory. This is the correct theory. Just use it. So the liquidity premium theory says 2-year bond interest rate should be equal to the average of the next two 1-year bond interest rate plus a liquidity premium of 2-year bond. Do you have I2T? Yes, 4% is equal to the average of, do you have I1T? Yes, 4%. Do you have I1T plus 1E? Yes, 3%. The question is asking for the liquidity premium. So 4% is 3.5% plus what? So square is 0.5%.